Okay, in this video we're looking at derivatives of e to the x. Now this relates to our Unit 3 work for maths methods. So we've got a few things that we know about e to the x. So if we have y equals e to the kx, its derivative is going to be ke to the kx. So basically what we're doing when we're doing the derivative of an e to the x type function, we're bringing down in front whatever the derivative of that exponent is. So if we have e to the 5x here, the derivative of 5x is 5, so then our derivative of that function is 5e to the 5x. So we don't make any change to the exponent, we just bring down the derivative of it. Here we've got y equals 3e to the negative 4x plus e to the x minus x squared. So we're just going to go through one piece at a time and do the derivative of those. So here we've got 3e to the negative 4x. The derivative of negative 4x is negative 4. So I'm going to bring that down in front. Negative 4 times 3e to the negative 4x. I know that the derivative of e to the x is just going to be e to the x. And my derivative of x squared is 2x. I'll then simplify that first term. So I've got negative 4 times 3 is negative 12. E to the negative 4x plus e to the x minus 2x is my answer. Now the next one you might look at and think that it's a quotient rule, but we can actually just simplify that first and work through a piece at a time. So what we can do is we can break each of these parts into its own fraction. So we can write e to the 2x over e to the x minus e to the x over e to the x plus 1 over e to the x. So then we can write that as e to the 2x over e to the x is just going to be e to the x, because 2x take away 1x is x. E to the x divided by e to the x is just going to be 1, and then we've got 1 on e to the x. So when we do the derivative of e to the x, we know that that's going to be e to the x. We can also write this one over here as e to the negative x. So I'm going to bring that over to the side over here for my derivative. So I know that the derivative of e to the x is just e to the x. My derivative of minus 1 is 0, and my derivative here will be minus e to the minus x as my derivative there. Then we've got one where it's a little bit more complicated. We've got a function up the top here of negative 2x cubed. So if you want to break it down and show those steps, you can write e to the u, where u is equal to negative 2x to the power of 3, and u dash is going to be negative 6x squared. And then write that y dash would be u dash e to the u, and put that u dash in, negative 6x squared e to the negative 2x cubed. So if you want to break it down a little bit further before subbing that in, you can do it that way. And then the last one we've got is y equals e to the x squared minus 4x plus 3x plus 1. So I'm just going to work through a piece at a time. My derivative of x squared minus 4x I know is going to be 2x take 4. So I'm going to put that out the front in a bracket and then pop my e to the x squared minus 4x in there. My derivative of 3x is just going to be 3, and my derivative of 1 is 0, so that's my answer there. Check if there is more marks allocated in case they do want to see more working, like I've included up the top there. In the next video, I'm going to look at an application of that where we're finding the gradient of the tangent.